So this is lesson 9-1, functions. So in this lesson, it says a function is a relation in which each element of the domain is paired with exactly one element of the range. So you might write these two words down somewhere, domain and range. Domain is your x values, range is your y. We've kind of mentioned that before. Then it says the domain, your x values, contains all values of the independent variable. So you might also write that down. X is your independent variable. Okay, so that means y is your dependent. When you think about what the word independent even means, like doesn't rely on anybody, can do it on their own. That's what it means here too. X doesn't rely on y. It's its own entity. So x is the independent variable. Y is the dependent variable. That means y depends on what x is. Okay, just like legally you depend on someone that you live with, your guardian. So y depends on what x is. So when we look at these two examples of whether something is a function, these are just like in bubbles. So this first one, remember, domain is your x values, range is your y, so that's a point. 2, 1, 4, 3, 5, 4, and 9, 7. Since we only have one line coming from each of these numbers in the domain, that is a function. So this one over here, our domain, we have 2, 5, 9. Over here, 1, 3, 4, 7. Do you see how this technically would mean the points 2, 1, and 2, 3, 5, 4, 9, 7. Since we have two lines coming from one on this side, this is not a function. Another one of these that I wish they would have shown, but they didn't, so I'm going to draw it. It might take me a second. I'll just use the same numbers that they have. 2, 5, I'm going to do 7, 9, 1, 3, and 4. So on this one, say we had this, and that 9 to the 4. Okay, so on this one, we have 2, 1, 5, 2, 5, 3, 7, 3, 9, 4. We had two of them that came to the 3 on this side. That is still a function because each of the numbers on this side have one line coming from them. You're only worried about your x values when you're trying to determine if it is a function or not. Okay, so this first example says determine whether each relation is a function and explain. So to determine if it's a function or not, we look at those x values. So on A, I have 54, 56, 55, another 54, and another 56 on this one. So this is not a function. And they put because 54 and 56 in the domain are paired with two range values. You could also say because 54 and 56 are there more than once. That would work too. Okay. Then on example B, we have a table. They give us x on top, y on bottom. So again, when we're just determining if something's a function, we only look at our x values. So I have 4, 7, 6, 3, 5, 2. None of them were repeating. They were all different numbers. So this is a function. And you would just say each domain is paired with one range, or each x value is paired with one y value. Okay, so I want you to try A and B, and then I'll go over it with you. On 1A and 1B, we're determining if they're a function. On 1A, remember when you're determining a function, if it's a function, you only look at the input value. Domain, those are all the same words for x values. So if I go back and look, I have a 5, 6, 7, 8. Since those are all different, yes, it's a function, and you can say each, we can either use the word input, domain, or x value. Has one y value or output. Okay, then on 1b, again, you're only concerned when you're looking at if it's a function or not, you're only worried about your x's repeating. So I come up here, have a 1, there's another 1. Okay, so that's the only ones that's repeating, so this is not a function. Even though we have two 2's down here, that doesn't matter for if it's a function or not. Only your x value. So you could say No, not a function, because there are, you could just say, two of the same x values. Okay, so now we're going to look at a vertical line test, and it means exactly what it says. So you can take your pencil and lay it vertically, which means up and down on your paper, on the graph, or on the screen, and you can test. If it ever touches the line, or if it ever crosses the line more than once in the same spot, it is not a function. If it only ever crosses once, it is a function. So same with points. If I line it up right here, it only crosses 1 point. Here, 1 point, you check all the way across. Here, 1 point. Here, 1 point. Let me do that in a pen. Here only once. Here only once. So since it never crosses 2 points, that is a function. Okay, so vertical line test. So then if I scroll down, determine whether the graph at the right is a function and explain your answer. You would just use that vertical line test. No matter where I cross this line, it's only crossing it one time. So this is a function, and you could say, because the vertical line test. That's enough to tell me why it's a function. Okay, so I want you to try number 2. You might draw this graph first, and then try that and explain your answer. On problem number 2, they give us a graph that looks like this, and it says, is it a function? So all we have to use on this is the vertical line test. Use your pencil. And it doesn't just mean in one spot. You have to continually check across your graph. So like if I put my pencil here, it only passes through once, which would mean it's a function. But if I keep looking, when I get here, it passes through both of these points at the same time. Also here and here. So this is not a function. And you could say, because of the vertical line test. You can say that because that means because of it passing through 2 points, it's not a function. So when we're looking at a function, so we have what's called function notation. So on here, this is what we've seen so far in equation, y equals 2x plus 3. Now we're going to see what's called function notation. It means the exact same thing, but now instead of y, you would say this as f of x. So f of x equals 2x plus 3. Still means the same thing, it's just now it's considered to be in function notation. Okay, so they both represent the dependent variable, your y. Okay, so when x equals 4, so if I plugged 4 in for x, 2 times 4 is 8, plus 3 is 11. You would say f of x equals 11. F of x is equal to the value of the function at x. Same thing for y. It's just another way that we're going to see it written. So with that, we can look at our next example. It says, if f of x equals 4x minus 7, find each function value. So for A, it says f of 5. That's how you would read that. That is a whole question. Like, what is f of 5? So what that means, you're going to take this up here, and you're just going to plug that value in for x and solve. Well, 4x means 4 times x, so f of 5 means I'm going to have 4 times 5 minus 7. So we multiply. 4 times 5 is 20, minus 7 is 13. So we just leave it that. F of 5 equals 13. It's the same thing as if we said y equals 13, but now it's in function notation. So then on this one, f of negative 6 means you're going to take that function, f of x equals 4x minus 7, and now plug in anywhere that you have an x, you'll plug in negative 6. So 4 times negative 6 minus 7. 4 times negative 6 is negative 24, minus 7 more is negative 31. So f of negative 6 is negative 31. So I want you to now go ahead and try both of these. We'll get some practice on that. 3A and 3B, and then I'll go over it with you. On the last examples, it says if f of x equals 14 plus 3x, find each function. On 3A, it says f of 4. Remember, all that means when we do f of 4, it just means anywhere that you have an x in that function, you now have a 4. That means 3 times x, so I now have 3 times 4, and now we just simplify this side. 3 times 4 is 12. 14 plus 12 is 26. So f of 4 equals 26. That's all you're having to do on that. Okay, so now on 3b, we have f of negative 7. So for f of negative 7, I take f of x, and anywhere I have an x, I now have negative 7. So I have to do 3 times negative 7. So I get 14 plus negative 21. That is the same thing as just saying 14 minus 21. Okay, when we do that, we get negative 7. All that, and the answer comes out to negative 7. So f of negative 7 is negative 7.